Hello. In this video we're going to extend what we know about Booleans. Excuse me one second. There we go. Extend what we know about Boolean values. And if you recall, a Boolean value was a true or a false. True or a false value. Sort of like a yes or a no. And we used them when we were working with if statements because we could write something like if, and then we had some Boolean expression. Maybe I'll write that in another color. If some Boolean expression evaluates to be true, then we went ahead and performed one set of statements, and otherwise we went ahead and performed some other set of statements. So in here we had statements. And recall, a statement is something that when we execute it has some sort of side effect, like the robot moves or turns or something. An expression is a piece of our program that we can evaluate. We can get a value, and the only two values we've seen so far are true and false, but later on we'll see how to evaluate expressions that give us all sorts of crazy things like numbers and words and so on. Okay, so we've seen some Boolean expressions. For example, we've seen robot on dark. We know how to write robot front is clear, and these are two Boolean operations that are given to us by the robot world. We also know that we can negate a Boolean expression. So if we negate robot on dark, we say not robot on dark. Then if robot on dark is true, then not robot on dark will be false. And likewise, not robot front is clear really means the front is blocked, because when front is clear is true, this will be false. When front is clear is false, we'll get back true. And we can use these expressions in here in the parentheses of for our if condition. Today we're going to extend that understanding, and let me introduce a problem I would like to solve. Here I have a robot, and the robot is in some sort of world, some sort of corridor, where there's some pattern of lights and darks on the left, and there's some pattern of lights and darks on the right. And the task at hand is for the robot to swap the pattern of lights and darks on the left with the pattern of lights and darks on the right. So for example, right now, looking down from the top, I see dark light, dark, dark. That means after swapping, the right side will be dark, light, dark, dark. And after swapping, also on the right, I see light, dark, light. So after swapping on the left, it will say light, dark, light, and so on. So we're swapping the colors on either side of the robots. So we're going to try writing this the way we might, knowing what we know, and then I think we'll get smart about it. So here I have a file called swap that I've already set up, public class swap, and in the braces I've defined a few methods to help me test, one of which is this test swap all one, which is actually what I ran to see this world. It loads swap1.txt, which is this map. It sets my robot to be nice and speedy, so 50 milliseconds between each operation, and it performs swap all, a method I'm about to write. And I also have a test swap all too, because not only might the world look like this, but I might have, in the same length corridor, I might have a completely different arrangement of lights and darks to swap. So I don't want to hardwire my program to handle just one pattern of lights and darks. That means I'm going to be using ifs and testing if there's a light or dark square as I go. So, first observation. In fact, let's bring up that picture again. Here we go. First observation. How long is my corridor? And I guarantee this corridor is always the same length. Well, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. 3, 6, 9, 10 rows. So I'm going to have to swap one row 10 times. So let's do that. So I'm going to assume I have the world's perfect method, swap one row, and that is going to be in my file called swap, which is the one I'm in right now. So swap.swaprow, that's going to swap the colors in one row. And apparently I know I need to do that 10 times. But also I realize that to get from the first row to the last row, I'm going to need to move 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So there will be 10 swaps, 10 swapping a row, and 9 moves. So that tells me I shouldn't move as part of swapping a row, since I won't move every time I swap a row. So probably what I should do is swap a row and then move. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 9 swap row and move, I will still have to swap the last row because I'll be sitting on the top row, but I haven't swapped it yet. And if you're thinking to yourself, why is Dave doing all this copying and pasting? There's got to be a better way. Why do I have to do all this copying and pasting in Java? Stay tuned, because soon enough we'll be learning about loops, and we'll see how to write this a lot cleaner and handle what if the corridor is longer or shorter. But for now, we'll just hardwire it to deal with 10 rows and therefore 9 moves from the first row to the last row. So next problem. Actually, let's go ahead and compile. So that's F5. I'm hitting compile, and it tells me can't find a symbol called swap row. Oh, that's right. I haven't written the swap row method. Well, let's write that now. Public static void swap row. Public, so I can call it. Static, I'm calling it on the file. Void, because it doesn't return a value. But for now, this is just an incantation we're writing. We're not really supposed to know what those words mean. Swap one row. How do I swap a row? Well, let's start by doing this the old-fashioned way. Let's see, I'm going to turn left, because that's the easier direction to turn. I'll move into this space, and I'll check if my robot is on dark. And every time I write an if, I recommend writing out the entire if as a fill-in-the-blank, and then we can fill in these pieces later. So here I know the left is dark, and I'm facing left. Or facing west, maybe. I don't know. We'll stick with left. Right. So otherwise we know the left is light and facing left. Well, if the left is dark, now I want to know, is the right dark? Because that will change. If both sides are dark, I don't do anything. But if the right is dark, I need to go back and swap the two. So let's see. That means I'm going to have to turn around. And I'm going to assume I have a method called turnaround in this file. I don't yet, but I'll write one soon enough. Turn around, move over to the other side. You know what? Let's be more clever about this. I don't like turn around and move. I'm going to do this in, I think, a nicer way. Instead of worrying about turning and moving and all that, let's write a couple methods that will make my life a little simpler. And this isn't really a new concept, but I think it's a helpful set of methods. I'm going to write a method called slide left. And slide left means the robot's going to slide over without changing direction, one position to the left. Of course, to do that, I need to turn left, move, and then turn right, and I will plan on writing a turn right method in this swap file, since my robot does not know how to turn right. It does know how to turn left and move, but turn right I'll have to define. And I'm going to write slide to the right to be the same idea, except slide right will turn right, then move, then turn left. So that will slide over one position to the right. That means I'm assuming that there is nothing to my right, otherwise my program will crash. And I guess I'll go ahead and define turn right while we're at it, since clearly I'm going to need it soon enough. Turn right is going to turn left 3 times. Okay, now how am I going to use this? Now I don't have to think so much about which way the robot is facing, because I am always going to use slide left and slide right, which don't change the direction of the robot, and I think that will make my program a lot simpler. So how do I swap one row? I slide to the left. See how much nicer that is? Slide to the left, check if it's dark. If it is dark, what do? Well, I slide to the right. You may be thinking, but won't that do a lot of unnecessary turning? Yeah, but I don't care. I like making my computer do more work so that my life becomes easier. So the left is dark, I'm sliding over to the right, and now I want to know, is the right dark? So, sorry, I'm going to write out my complete if. Let's expand this so you can see more of what's going on. So here we go. I've got slide to the left, go into this position, check if it's dark. If it is, I make a note for myself. This doesn't actually change what my program does, that the left is dark. I slide to the right twice, so I'm on the right side. I check if that's dark. If it is, both sides are dark. So there's no swapping to do. If both sides are dark, I just leave it alone. I'll just return to the center, like so. On the other hand, here I know that the left is dark and the right is light. That means I need to swap the two. And I'm sitting on the right, so I can begin by making that right cell dark, and then I'll slide to the left, slide left twice. So I've made this cell dark, I go over here, and now I need to make this one light. So actually that's sort of like, let's see, that's like this situation over here. Left is dark, I slid right, I discovered it's light, I need to swap, so I make this dark, and I'm sliding back to the left, sorry, to make that light. Good. And then I'll slide back to the middle. And now, of course, I need to do all that mess again for the left being light. Okay, so if the left is light, now I need to slide over to the right. Slide right twice. That gets me to the right-hand column. So I know the left is light. I want to know, what about the right-hand side? So is the robot now on a dark, now that the robot is on the right? And I recognize I'm going pretty quickly, and that's because the way we're writing this code, this is not a good program. I mean, it's okay, but we're going to make this a lot neater when we understand Booleans better. So I'm deliberately sort of flying through and showing you some of the craziness of writing this, of solving the problem using only what we know so far. So we'll slide to the right. We'll check if we're on dark. If we are, then we know the left is light and the right is dark, so we have some swapping to do. Otherwise, and I'm noting this here because I'm going to forget later. Otherwise, I know that the left is light. Actually, I know both are light. In fact, I'll deal with that now. If both are light, I just need to slide back to the middle. So slide left again. And that's because I really have an implicit rule here. I know that, precondition, actually, I used the word before and after before. Before, robot is in the middle row, and it's facing north, and afterward, the robot is in the middle row facing north, and has swapped left, right colors. Alright, so back to where I left off. Sometimes I make little notes for myself of where I left off. Left off here. That way when I hit compile, it will take me back to that line and say, oops, you didn't write that line yet, because that doesn't look like Java. Okay. Left is dark, left is light, the right is dark. That looks like this, or actually on the row that the robot's on right now. And I'm on the right-hand side, so I'm on the dark square, so I'll just make it light. I will slide over to the left, just copy and paste that from here, slide over to the left twice, make the left-hand side, now that I'm there, make that dark, and then slide back to the right so that I'm in the middle. Let's see if we got it all first try. That never happens, right? I hit compile. It's going pretty quickly too. So I don't know that I feel too super confident here. Test swap all. Ooh. This is looking pretty good. It shouldn't swap any. They're both dark. Oop, here it should swap. It did. Here it should swap. It did. Oop, oop. Oh, I'm feeling good about this. Don't crash, don't crash, don't crash. All right. It does swap everything. Okay. Thank you very much. That is how not to write this program. In the next video, we'll take a look at a much cleaner way of writing this program that will be much more like the way we might think in English, whereas here we might argue we are thinking like the robot in Java. I'll see you in the next video.